Hello friends, welcome back. Hearty welcome to you. Let's try to solve some geometry problems related to 9th and 10th class for competitive exams. In the given figure, three semicircles are drawn on three sides of triangle ABC. AB is 21, BC is 28, AC is 35. What is the area of the shaded part? We have been given that three semicircles are drawn on three sides of triangle AB, BC and AC. We have to find out the shaded region. Now let's try to write down what is the shaded area. Shaded area is equal to, let's write down what we need to find out is area of triangle ABC plus area of semicircle with diameter as AB plus area of semicircle with diameter as BC minus area of semicircle with diameter as AC. Now this is what is the shaded area. Now what is area of triangle ABC? So let's have a look at these sides we have here. We have 21, 28, 35. 21, 28, 35. If you try to simplify them, they are in the ratio of 3:4:5, which are Pythagorean triplet. That means 21, 28, 35 is a right angle triangle with 21, 28 and 35. So area of the triangle can be easily identified, that is half into base into height, which is half into 21 into 28. Simplify that, we'll get 21 into 14, which is equal to 294 cm square. So our answer is 294 cm square. Now what happened to the remaining part of the problem? They will nullify because area of semicircle with dia as AB plus area of semicircle with dia as BC will be equal to area of semicircle with dia as AC. How it is? Let's try to understand that. We know this angle is 90 degrees. That means we know AC square is equal to AB square plus BC square. Now once we know that, let us say multiply with pi divided by 8. Pi by 8 into AC square is equal to pi by 8 into AB square plus pi by 8 into BC square. That's exactly equal to half into pi into AC by 2 whole square is equal to half into pi into AB by 2 whole square plus half into pi into BC by 2 whole square, which are nothing but area of semicircle with diameter as AC is equal to area of semicircle with diameter as AB plus area of semicircle with diameter as BC. So this cancels out. Our answer is only area of triangle ABC, which is 294 cm square. Why? Because we know that it's a right angle triangle, hypotenuse square equal to sum of square of remaining two sides. Now once we know that, we know the properties that areas described on the circles or semicircles will be square of them will be equal to square of the hypotenuse. Let's go to the next problem. Three circles C1, C2, C3 with radii R1, R2, R3 are placed as shown in the given figure. What is the value of R2 in terms of R1 and R3? To solve this problem, what we will do, we'll try to get similar triangles because we know we have 90 degrees whenever there is a point of contact between circle and the tangent. So let's try to draw a parallel line to this line, and that line will be like that. This line and this line are parallel to each other. Now let's try to draw this triangle separately and see how we can use similar triangles to solve this. Now once we have drawn the circle, let's try to put some alphabets there. Let us say this is X and Y. we know these two triangles are similar to each other because they have a common angle and they have 90 degrees. So this triangle, we have taken it, we have flipped it, and we have placed it here. Now they are similar triangles. Let's write down the values here. What is C1, C2? The circles are touching with each other, so this will be R1 plus R2. And C2, C3 will be, again the circles are touching with each other, that will be R2 plus R3. Now what is C2x? This is our x and this is our y. If you can see, C2x is R2 minus R1 and C3y is equal to R3 minus R1. We can write down the corresponding sides now. Since we have common angle and we have 90 degrees, let's write down. We can write down R2 plus R1 divided by R2 minus R1 is equal to C1 C2 by C2x. I'll write down here. C1 C2 by C2x is equal to C1 C3 divided by C3y. What is C1 C3? C1 C3 is R1 plus 2R2 plus R3 divided by C3y, that is R3 minus R1. Now to solve this problem, we'll be applying componendo and dividendo. Once we do that, let's write down what is componendo dividendo just for reference. If A by B is equal to C by D, then A plus B divided by A minus B is equal to C plus D divided by C minus D. This is very useful technique to solve some of the complicated problems. So let's go ahead and apply that. When we add them, we will have R1s cancel, so we will have 2R2. When we subtract them, we will have R2s cancelling it out, so we will have 2R1. When we'll add on the other side, we'll have R1 cancel, we will have 2 into R2 plus R3. When we subtract, we will have R3 cancel it out, so we will have 2 into R1 plus R2. Now you can cancel 2 here. Let's do cross multiplication. We will get R1 R2 plus R2 square is equal to R1 R2 plus R1 R3. R1 R2 again will get cancelled. We get R2 square equal to R1 R3. That means R2 equal to square root of R1 into R3. So our solution is R2 equal to square root of R1 into R3. Let's have a recap of this, how we have done that. We have been given that three circles are placed with radii R1, R2 and R3 are placed in such a way that, as shown in the figure, we have to find out what's value of R2 in terms of R1 and R3. So we have drawn a line parallel to the common tangent. Then we see we have similar triangles. We have taken that and we have flipped it. Remember, C1, C2, C3 are hypotenuse of this respective triangles, hypotenuse. So then we have C1, C2 by property, we know R1 plus R2, C2, C3 is R2 plus R3. Similar triangles, corresponding sides are proportional. By applying componendo and dividendo, we are able to solve that and find out R2 equal to square root of R1 R3. Let's go to the next problem. In the given figure, PQR is an equilateral triangle with side as 12 cm. S and T are midpoints of the sides of PQ and PR. What is the area of the shaded region? So let's try to solve this problem. First, we know that PQR is an equilateral triangle and also S and T are midpoints. That means, let us say this is the height of this triangle, which we know is equal to root 3 by 2 into side, which is equal to 6 root 3. We'll keep it handy because we need the area of shaded region, that is half into base into height. So I need to find out this height. So let us from P, let us drop a perpendicular. Now let us put some alphabets there. Let us say this is X and this is Y. So if Py is equal to 6 root 3, then what will be Px and Xy? Because it's a S and T are midpoints, then we know two things. One, ST is parallel to QR. Also, we know ST equal to half of QR. This we are getting by midpoint theorem. Also, we know in the similar triangles, the corresponding sides and the corresponding heights are in the same ratio. That means this total 6 root 3 is divided into 3 parts. One is 3 root 3, another is 3 root 3. That means we know that xy px equal to xy is equal to half of 6 root 3, which is equal to 3 root 3. But what is that we are interested in? We are interested in, we haven't taken this point. We have to take another point. Let that point be z. This point is z. Let's draw this triangle again so that it will be more clear. Now we have drawn this triangle again. Whatever we have here magnified, we have ST and QR parallel to each other and ST equal to half of QR. And you can observe that SZT and RZQ are similar triangles because ST is parallel to QR and we have the corresponding sides are in the ratio 1:2. That means these heights xz and zy also will be in the ratio 1:2 only. But what is xy? We know xy is 3 root 3. That means we have to divide that in the ratio of 1:2. So this will be root 3 and this will be 2 root 3. How we got it? 3 root 3 into 1/3 and this is 3 root 3 into 2/3 because this ratio is 1:2. Yes, we know that these two triangles are similar to each other with alternate interior angles. We have parallel lines there. If I haven't drawn that, these are parallel lines. So we have AA similarity criteria. The heights are in the ratio 1:2. Now that is what we need actually, ZY. So let's go ahead and write down now the area of shaded region. That's equal to half into base QR into height ZY. But we know half into QR is 12 into ZY. Just now we found out that is 2 root 3, which is equal to 6 into 2 root 3, which is equal to 12 root 3 cm square. So let's have a recap of this problem. What we have done, we have been given in an equilateral triangle PQR. We have to find out the area of shaded region. What we did, first thing we know that S and T are midpoints. That means PST is similar to PQR triangle. That means the heights are divided in the ratio 1:2. So PX by PY is 1/2. That means PX equal to XY. But what is PY? We know that is root 3/2 into side because it's an equilateral triangle, that is 6 root 3. Divided into two parts, 3 root 3, 3 root 3. Now look at these two triangles. These small triangles, we have chutkus here. We have SZT and QZR. These are again similar triangles divided in the ratio 1:2. As we know, ST is parallel to QR. Alternate interior angles are equal, vertically opposite angles. Corresponding sides are in the ratio 1:2 because we know by midpoint theorem ST equal to half of QR and ST parallel to QR. Now if the sides are in the ratio of 1:2, the heights also should be in the ratio 1:2. That means 3 root 3 is divided in the ratio of 1/3 into 1/3 into 2/3 or 1:2. So then ZY becomes 2 root 3. We are interested in ZY. We got what we need. So we can go back and substitute half into 12 into 2 root 3. The answer will be 12 root 3 cm square. Let's go to the next problem. In the given figure, PQRSTU is a regular hexagon of side 12 centimeters. What is the area of triangle SQU? First let us see what type of triangle is SQU. We know that in regular hexagon the angle is always 120 degrees between the sides. So this angle is also 120 degrees. We know this angle is also 120 degrees. Now we also know that all the sides are equal. That means all these are isosceles triangles PQU, TUS and QRS. Now let us see what is the angle at PEQ. That will be 30 degrees because 120 plus 2x is 180. Similarly on the other side also 30 degrees. That means we know this triangle what we need SQU is a equilateral triangle. All angles are equal to 60 degrees. Now once we know that, now the problem becomes easy because area is just simply equal to root 3 by 4 into QU square. Now only the thing left out is how to find out the value of QU. For that, what we will do? We will take PEUQ triangle separately. We'll drop a perpendicular. Then we will have PU equal to 12. We know that. We have to find out QU, but we know this angle is 30 degrees. So we can leverage that and find out what is UQ. Can I write down? UQ equal to 2 into UX, but that is equal to 2 into PU into cos 30. That is equal to 2 into 12 into root 3 by 2. 2 cancels, which is equal to 12 root 3. Once we know QU is 12 root 3, now this is pretty simple. Root 3 by 4 into 12 root 3 into 12 root 3. Let us simplify that. 4 will go 3 times. We will have 36 into 3 into root 3, which is equal to 108 root 3 cm square. Let us have a recap of this simple problem. It is, first we understood that this is an equilateral triangle. Why? Because we have PU equal to PQ and we know all these angles are 120 degrees. Isosceles triangle. So 30 30 30 30 left out is 60 degrees. That means I have to find out QU length. Then the formula is root 3 by 4 into QU square. How to find out that? Drop a perpendicular. You have 30 60 90 triangle, which is 1 root 3 2. Now PU is 12, that means UX will be 6 root 3, that means UQ will be 12 root 3. You don't need to do this calculation, you can just put down 1 root 3, 1 root 3 and 2, 1 is to root 3 is to 2. So in that ratio you divide them, you directly get 6 root 3, that means it is 12 root 3. Or trigonometry, same thing only. You can say cos 30 equal to root 3 by 2, root 3 by 2 equal to UX by PU, that means UX is PU cos 30. Which is 12 into root 3 by 2. You have to multiply that with 2 to get UQ. Then our area is root 3 by 4 into QA square. Simplify that. Root 3 by 4 into 12 root 3 into 12 root 3. That is root 3 by 4 into 432. 4 will go 108 times. 108 root 3 cm square. So those are some examples or problems which were asked last year. I just thought of sharing with you. Please do let me know your feedback. Thanks for your time and support. Bye for now. I'll catch you once again. Till then, keep smiling and sharing. Bye.